Saturn. Saturn is the sixth planet from the Sun and the second largest in the Solar System, after Jupiter. It is a gas giant with an average radius about 9 times that of Earth. It has only 1/8 the average density of Earth, but with its larger volume Saturn is over 95 times more massive. Saturn is named after the Roman god of agriculture. Its astronomical symbol represents the god's sickle. Saturn's interior is probably composed of a core of iron, nickel and rock, silicon and oxygen compounds. This core is surrounded by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen and liquid helium, and finally a gaseous outer layer. Saturn has a pale yellow hue due to ammonia crystals in its upper atmosphere. Electrical current within the metallic hydrogen layer produces Saturn's planetary magnetic field, which is weaker than Earth's, but has a large magnetic moments because of Saturn's large radius. Saturn's magnetic field strength near the equator is around 1/20th the strength of Earth's. The outer atmosphere is generally bland and lacking in contrast, although long-lived features can appear. Wind speeds on Saturn can reach 1,800 km per hour, 1,100 miles per hour, higher than on Jupiter, but not as high as those on Neptune. In 1610, Galileo Galilei became the first person to observe Saturn through a telescope. He noted that it appeared to have ears, and he described it as a triple star system. Christian Huygens, however, believed that it was a planet, and in 1659 he discovered its largest moon, Titan. Huygens also observed that Saturn's rings were composed of countless small particles. In 1789, William Herschel discovered the planet's second largest moon, Rhea, and 2 years later discovered 2 more moons, Dione and Tethys. In 1848, William Bond and John Adams discovered 4 more moons, Mimas, Enceladus, Hyperion, and Phoebe. Between 1897 and 1900, Titania and Oberon, 2 more moons of Saturn, were discovered by English astronomer William Lassell. In 1966, the American astronomer Richard Pogge discovered that Saturn's F-ring was composed of small particles. The most recent discoveries have been made by the Cassini spacecraft, which has observed Saturn and its moons since 2004. In 2008, Cassini discovered 2 small moons, Helen and Polyjuices, orbiting between the F-ring and D-ring. In 2009, it discovered the ring planet's 16th moon, Daphnis, and in 2010, 2 more moons, Aegea and Anthe. The rings of Saturn are one of the most fascinating and beautiful features of our solar system. They are composed of billions of tiny ice particles, ranging in size from a few microns to a few meters, that orbit Saturn in a plane almost perpendicular to the planet's equator. The rings are very thin, with a thickness of only a few meters, and are widely separated from each other. The most prominent feature of the rings is the Cassini division, a gap between the innermost ring, the D ring, and the outermost ring, the A ring. The Cassini division is about 4,800 km wide and is due to the gravitational influence of Saturn's moon, Mimas. The rings are thought to have formed from the debris of comets, asteroids, and moons that were destroyed by Saturn's gravity. The most likely source of the material is Saturn's largest moon, Titan, which is thought to have had a much larger moon in the past that was destroyed by Saturn's gravity. Back in the early days of space exploration, Saturn was a bit of a mystery. Scientists have been able to recreate this and other geometric shapes in the lab, possibly explaining what's happening here, but it's not clear what would be driving the rotation that has been discovered to be necessary for the effect. We also don't know exactly how stable the cloud formation is, or how long it will last. Some scientists suspect that since the rotation rate appears to be the same as the emission rate of radio waves from the planet, yes, Saturn is giving out radio signals, this could reveal the rotation speed of Saturn's core. However, its thick atmosphere stops us from seeing more of what's going on. The elegant rings which surround the gas giant can be seen from our own back gardens on a clear night with little more than an amateur telescope, and while they are Saturn's defining feature, it doesn't necessarily mean we understand them. Cassini observed molecular oxygen is 2 oxygen atoms bound together. This is the most common circumstance in which oxygen is found here on Earth. in the rings and thin atmospheres of Saturn's moons. This discovery has led to great discussion, since molecular oxygen is generally made in organic processes by living things. This is not the only way molecular oxygen is formed, of course. Geological activity can also produce it, or even, less often, radiation on water molecules. Voyager also noticed something strange about Saturn's rings as it flew past. One of its darker bands, the B ring, showed radial lines going through it like spokes on a bicycle wheel. These lines troubled astronomers because they couldn't be explained by gravity. What's more, photos from Cassini sometimes showed evidence of these spokes and other times showed no trace at all. Astronomers agree that the lines must be short-lived and sporadic, appearing randomly in the ring structures for a few hours before being wiped away. Some scientists think they may be a result of Saturn's magnetic field, while others believe it could be due to lightning storms in the planet's atmosphere. Even more of a mystery, and perhaps a more obvious one, is where exactly did those rings come from? We have been able to see them for over 400 years now, and yet we still don't really know how they got there. From looking at the light coming through the rings, scientists have been able to determine their composition: ice, water and a little bit of space dust. Just like your mirror, astronomers expected the rings to reflect less light and become duller with age as more and more dust settles in the bands. The fact that they are still bright led us to believe that the rings were new. However, new evidence suggests that the rings refresh themselves often when the material collides with itself within the rings, giving them the appearance of being younger than they really are. Scientists are still unsure how so much water and ice ended up in the atmosphere around Saturn. Scientists are studying the hurricanes on Saturn in an attempt to better understand their formation, intensity and movement here on Earth. The difficulty with collecting data from hurricanes is that the parts of interest are just too turbulent and dangerous to enter. Current devices cannot stay in the storm long enough to collect clear and conclusive data. Saturn's hurricanes are more static than those on Earth and don't have oceans to contend with. So far, forecasters are learning better how to predict hurricanes on Saturn, but will it translate to Earth, where warm oceans are considered a source of the initial hurricane energy? We do this by turning on the heating when it's cold, and opening windows or using air conditioning when it's hot. This adjusts the A state of balance where temperature remains constant because the energy in matches the energy out. The balance between total energy coming in and going out. All objects obey, or are supposed to obey, this simple law. If you put more energy in, it gets hotter. The hotter it gets, the more energy it radiates away, until the energy coming in is the same as the energy going out. They range in size from the giant moon Titan, bigger than Mercury, to smaller than a sports arena. Titan's atmosphere raises more scientific questions. The amount of nitrogen suggests it may be older than Saturn itself. As the only known satellite with more than a trace of atmosphere, isotopes are being studied to try to work out what's going on. Methane has also been found in the atmosphere using Earth-based telescopes and confirmed by the Cassini mission, but we don't know where it comes from. Calculations suggest that this methane ought to have been broken up by cosmic radiation within 50 million years or so, a very short time when compared to the age of the Solar System itself. Therefore its present abundance seems to indicate that the methane in the atmosphere is being replenished from a source on Titan. Methane is usually associated with organic processes involving life, but can be made by volcanic features which release water and other gas, liquids with low melting points, on colder worlds than our own. As a result, we have no good images of the Titanian surface, and so can't identify the source of the methane. With an atmosphere thicker than our own, scientists also wonder how Titan's atmosphere circulates. Its seasons are 30 times slower than ours, so observations require patience. However, scientists have observed a rotating vortex over the South Pole, hinting that the atmosphere rises in the hemisphere experiencing summer and falls at the winter pole, but we cannot yet say for certain that this is the case.